All right, and we live again. So first of all, before I really start this video, let me just say I apologize that I'm late with this video. I wanted to have this posted Friday night or sometime Saturday, but I got caught up in running errands and performing household chores and so on and so forth. So I'm actually recording this in the late evening of Sunday. Matter of fact, it's after 6 o'clock right now, so my apologies, but we're gonna get her done. This video is gonna wrap up lesson 24. We started lesson 24 on Friday. We got through most of it, or at least half of it, but I did want to record this video so you guys can finish it out independently. This is not difficult. In lesson 24, we're really just revisiting equations once again that involve square powers and cube powers, as well as square roots and cube roots. And then towards the end, we're going to solve for various x values, which is a skill that you should have learned last year in 7th grade that I will review a little bit as well. I'm going to try to keep this video short, maybe 10 or 15 minutes, but don't quote me. We'll see how we do. Okay. First of all, this was our warm-up the other day. Really, we're just given some perfect squares and or perfect cubes and some not so perfect squares or perfect cubes, and we need to determine whether if it's rational or irrational. I'm not going to go through it, but I will explain that rational numbers are they can be positive and negative, but they are typically perfect squares and perfect cubes, and irrational numbers typically are not perfect squares and are not perfect cubes. Also, rational numbers will terminate, meaning you will get one solid number, or it'll be a continuous number, meaning the number might be 1.33333 and keep on going. Whereas an irrational number, either it won't terminate and or it'll just be a bunch of random decimal numbers with no real pattern attached to it. So that's how you determine whether these given root values are rational or irrational. Just a little bit of review there. This was number 1. I will not do all of this. I'm just going to maybe do 1 or 2 and go through it. I gave you guys the first column that you have here. It says to indicate whether if the value of x is a solution to the given equations. Our values of x are right here. We're given 1 and then we're given -1. If I plug in 1 for this x squared value here, and I put 1 squared, 1 times 1 is still 1, so yes, that would be a solution because that is what we're looking for here. If I plugged in -1 squared and got 1, yes, that is a solution. Now, I'm just going to skip over and let's just do this third one here. This x squared plus 1 equals 2. If I plug in the value of 1, +1 for x squared plus 1, that will give me 2, so it is a solution. But if I plugged in -1, let's see what we get. -1 squared is +1, plus that extra 1 from the equation, that will still give me +2. So that is a solution in this case as well. And then for the other 3 columns, you just continue to plug in and determine if you get the same answers on both sides of the equal sign. If you do, then it's a solution. If you don't, then it's not a solution. Pretty plain and simple, right? Not bad. For number 2 and 3, it says to solve for the x values and or the variables that you're given. So we're really just solving for the equation here and identifying all solutions. I did leave a note that perfect squares, which is what we have in this case just because we're given squared values, have 2 solutions and not 1, which would be a positive version of the answer and then a negative version of the same answer. So for number 2, we're given x squared equals 25. If I want to find the value of x, because that is what we're looking for, then I have to square root 25. Whoops. The square root of 25 is 5, but you can also use +5 to get 25 as well. Plain and simple. Let me see. I think we got some more. Yeah. I'm going to jump down just a little bit. and skip number 3 because we did number 3 in class. I'm going to go to let's do number 4. Number 4 gives x squared equal 35. Once again, I would have to square root 35 to get an answer, but the square root of 35 is not a perfect square. Yes, we can kind of round it off a little bit, and we can determine that the decimal number would probably sit somewhere in between 5 and 6. So I'm just going to make a note between 5 and 6. But it is not perfect, therefore there is no solution in this case. Plain and simple, that's it. If it's not a perfect square, and if it's not a perfect cube, it'll just stay in its square rooted version, or its cube rooted version, or there's no solution at all. And then we leave it be, unless you're asked to go further, but in this case you are not. I'm going to leave those practice questions there for you guys to do on your own. Here, same thing, except for we're working with cube roots. When we get to number 8. For number 8, we have t raised to the 3rd power, so t cubed equals 27. So if I want to get the value of t, I have to cube root, not square root, but cube root 27. Just off the top of my head, I know that 3 times 3 is 9. Times 3 again is 27. So I know the cube root of 27 will give me 3. But that will not work for negative values. Remember that cube roots only have one solution. Okay? Not 2 answers, just one. I'm going to scroll down just a little bit. Let's do let's do number 11. Number 11 gives us negative 8 equals r cubed. Same thing. We're going to set it up and set up the cube root of negative 8. Off the top of my head, I know that 2 times 2 is 4 times 2 is 8. But if I use negative 2 times negative 2, that'll give me positive 4. And then positive 4 times that same negative 2, if I raise it to a cube root, will give me negative 8. So our solution here, r equals negative 2, is how you work that out. Worst case scenario, if you're unsure, just plug it into the calculator. You'll still get the same answer. Now, should you be able to do this off the top of your head? Yes. But if you're struggling and you have a calculator on your side, just go ahead and put it to work. Work smarter, not harder. All right? Here, this is something I really wanted to get into, but we didn't really have time. For number 14, it says that Dylan solved the equation x cubed equals negative 64 on his homework, but he made some errors. His work is shown. Help Dylan correct his math work. And it does show the equation here. And this is his math work on both sides. Okay? He seemingly put it into a calculator, or was trying to do some mental math, better yet. And he did the cube root of negative 64, and he got negative 8. Or he did it again and used positive 8. So he's basically saying that this cube root has 2 answers, negative 8 and positive 8. If you remember what I said, cube rooted numbers only have one solution and not 2. So this is definitely incorrect. Okay? Now you can plug this into a calculator, or you can do this off the top of your head. But how you find the mistake is just backtracking and seeing where he went wrong. Now, his setup is correct because he did cube root negative 64 as he should have to find the value of x, but the 8 is what's incorrect. Because if you put it in the calculator, or if you're just that good and you can do it off the top of your head, you would know that the cube root of negative 64 will first of all be a 4, just because we know that 4 times 4 is 16, times 4 again is 64. But to get that negative value, I have to use negative 4 times negative 4 to get positive 16 again. But then we multiply it by negative 4 one more time, and that will give us the negative 64 we were looking for. So x really equals -4, and it is one solution. But you just need to be able to tell where he went wrong at and be able to assess work that is or is not correct, is what this practice question is. Please do take note of this. If you have not already, put a star by this. Okay? All right, here we go. For problems 15 and 16, solve the equation, show all steps. For these equations, all you're really doing is solving for the x values, except for now you are given equations. I think I did number 15, but I guess I'll just work out 15 and 16 for you and then leave the rest for you to solve on your own. Okay? For 15, we have 2x plus 1 equals 17, and we need to solve for the x value. First of all, you want to eliminate all standalone numbers, meaning that +1. Any operation you do on one side of the equal sign, you have to do it on the other side, and you have to perform the opposite operation, meaning we have +1 here. So if I want to eliminate that, I need to do -1 so we can cancel it out. But I have to do that -1 on both sides. That would give me 2x equals 16. Now this 2x also means 2 times x. Oh, there we go. It also means 2 times x. So we can divide, since this technically is multiplication, and we can divide by 2 on both sides. 16 over 2 gives us 8. So x equals 8. Plain and simple. Here, I'll do it one more time for 16. I'll do 16 in blue. For 16, we have x squared equals 1. I'm sorry, x squared plus 1 equals 17. I was reading ahead of myself, so my bad for the little blooper. Once again, we're going to eliminate the 1 and just perform the opposite operation so we can cancel it out. That gives us x squared equal +16. We have a square root here that we're going to perform because we have a squared power over that 2. That'll give us a singular x equals the square root of 16. Now you can do this in your calculator or you can do it off the top of your head, but if I square root 16, that's basically asking what number multiplied to itself or what number raised to a squared power would give us 16. I know that 4 times 4, or 4 squared, equals 16. So our answer for x is +4. Boom, bam, with done. Or, once again, because I gave the reminder at the beginning of this presentation that all square rooted values have 2 answers, positive and negative. So we can also make -4 work as a solution as well and get the same answer. Done. If you need to pause a little bit to write, go ahead, but I'm moving on. I'll leave 17 through 20 as some independent practice for you, but remember that regardless of what solution you get, whether if it's a whole number, a square root power, a cube root power, or whatever, just make sure you follow all the directions and determine whether if they are rational or irrational. All right? If you need a reference on what rational and irrational is, make sure you reflect in your book for the definitions, or you can rewind this video and get the definitions I just gave you out of my mouth on what rational and irrational numbers are. But that is some practice for you to do. This is a debrief. I usually don't like debriefs. I personally think they're a waste of time. That's why we don't do it. But I will read it off right quick and just give you some tips and hints if I can. The first question is, how are the solutions to x squared equal 100 and x squared equal 10 similar, or how are they different? First of all, the solutions are similar in the way that you'll have to square root both of these answers in order to get a solid answer for x, but they're different because 10 cannot be square rooted into a perfect number because it is not a perfect square, but 100 is. Okay, the square root of 100 will give you 10. Whereas with x squared equals 10, you'll just keep the square root of 10 if you don't need to solve any further than that. Okay, and it's kind of the same thing for the other two questions below. Either it's a perfect square or it's not. Either it can be broken down or it can't be. Same thing with cube roots. Nothing too special. This was your exit ticket. I do believe everybody turned it in, but if you held on to it for whatever reason, I will explain right quick that for problems 1 through 2, you just need to solve for the value of x. Number 1 is a squared power for x. Number 2 is a cubed power. So I'll just say make sure you are checking your answers properly and you are solving properly. At the end of it, determine whether if it's rational or irrational. I will say make sure you show all of your work. Show all of your work, even if you put it in the calculator. Set the equation up for what you put in the calculator on your paper. That counts as showing your work. Okay? Do it for number 1 and 2 and turn it in if you have not already. Your homework for lesson 24 is number 1 through 9. It is 10 points apiece. I'm sorry, it is 10 points as a whole, 1 point apiece, just about. Matter of fact, I think number 1 is 2 points because number 1 has 2 answers and the rest is 1 point. There we go. It's only 9 questions. If you have not done it, go ahead and knock it out so you can turn it in ASAP because grades are due on Thursday. I am not accepting work past Wednesday. At the latest, depending on how much work it is, I might take it on Thursday, but after Wednesday, that's my preferred cutoff. So make sure you get this in so your grades can be accurate for when report cards come out next week. And we are done.